Hello, this is Maria from Math Mammoth, and this is Matty, my mascot. In this lesson, we're studying some exponent laws, and we will start with product of powers. Here you see 5 to the 6th times 5 to the 3rd. So we have two powers, and they both have the same base, 5. And we're going to find a way to write this expression in a shorter manner, simplify it. What do you think? This 5 to the 6th means, of course, 5 multiplied by itself 6 times. And then it is multiplied by 5 to the 3rd, so 3 more times. So we see that this is actually 5 to the 9th, right? 5 multiplied by itself 9 times. So what happens here then? Can you tell? We can write this out. X to the 9th would be x multiplied by itself 9 times, right? There will be lots of x's here. And then over here we have x and x. Still more. So total would be x multiplied by itself 11 times, x to the 11th. It's a simple law, right? Or simple rule. In general, let's write this rule or law now using just variables. So we will have x to the mth power times x to the nth power. And that can be written in a shorter way as x to the sum of those exponents, m plus n. Okay, let's simplify this one. Can you tell what we will get? Think about it for a moment. How many copies of a will be multiplied here? We have a to the 8th, a to the 7th, so we would have 15 copies of a. But this one here is a to the 1st power, so we need to count that too. There's 15 copies of a, and then 16, 17, 18. A to the 18th. Now in this one, we're going to simplify it. We're going to write it in a shorter way using the fewest powers and fewest bases possible. We have here 9 and 16, 2 cubed, 3 to the 6th. And then times 3. So we have at least two bases, 3 and 2, 16. Well, it so turns out, you probably know, that 16 can be written as a power of 2. 16 is actually 2 to the 4th. And then 9 is 3 squared. Okay? So now we actually have just two bases in this entire expression. So we can write it as 2 to some power times 3 to some power. So looking at 2, we have 2 to the 4th and 2 cubed, so that would make 2 to the 7th. And then 3, we have exponent 2 and 6, that makes 8, and one more, because you can think of here as being exponent 1. So 3 to the 9th. So that's our simplified expression. Now let's look at quotients of powers with the same base again. So we see here y to the 4th divided by y to the 7th. If I write this out, I mean, you can probably guess what happens. Here we have y times y times y times y here. In the numerator and denominator has y's also, but 7 of them. And so some of them will cancel out. This with this, this with this, this with this, this with this. It leaves 1 here at the top. And at the bottom, we have y times y times y, y to the 3rd. Let's do the same with this one. Can you tell what will happen? Y to the 8th power, so we would have y, 8 copies of it here. And then on the bottom, just 5 copies. And we cancel. Leaves 1 here. Leaves 1 here too, but we don't really need it. 1 times, you know, those. And so now we just have 1 here on the bottom. And y, it's y cubed. In general, we can summarize this using variables that if we have x to the mth power and then divided by x to the nth power. So we have x and x at the same base. This will simplify so that the exponents are subtracted. This could sometimes produce a negative exponent, by the way. And we're going to look at that in the next lesson. Okay, lastly, let's simplify this expression. We have 9 and then 3 to the 8th divided by 3 to the 6th, and then there's 27. Looking at it, you probably noticed that 9 and 27 are both powers of 3. So let's write them like that. 9 is actually 3 squared, and then we have 3 to the 8th, and here we have 3 to the 6th, and 3 cubed. As a next step, we could already cancel something out, but let's first simplify just the top part here. The numerator becomes 3 to the 10th, and this one becomes 3 to the 9th. And now we use the second law of exponents, the rule where we subtract the exponents. 10 minus 9 is 1, right? 3 to the first power, which is just 3. So that really simplified nicely. Okay, we're done with this lesson and I hope it was helpful.